Thank you. Appreciate the opportunity to be here. I'm also joined by Kevin Peterson, who will actually be going through the presentation. Kevin is our solutions architect and works with me to support the eastern side of North America. So I was actually at one of these Think Big events last year in up in Richmond, and I must say I miss the casino night. So maybe we'll be able to get a rain check on that.
Yeah, I think everyone does. You're not alone on that. I'm getting about 5 different IMs right now as you make that comment.
So real quick, in the vein of think big, start small, connect anywhere, we truly believe that our solution here at tempered.io is a big solution. I mean, you really can think big with what we can do, but definitely start small and calculate it through the process. And actually it fits the connect anywhere theme. So with that, I'm going to turn it over to Kevin. I'm going to allow him to give a quick background on his experience. He is familiar with what you guys do. So Kevin, it's all you.
Hey, thanks, Brian. And I gotta say, hats off to Toby too, because I rode WorldTech through the GE acquisition and some of those. So it was sort of like coming home watching the last part of your presentation, because I was the guy with the hard hat and installing those devices on the GE power gen station. So
outstanding.
Yeah, it was fun. So I miss the days, but I don't. So, but it's all good. So that's part of the background. I did mostly DoD for Siemens. That didn't include a lot of ICS, as I just said too. I ended up at GE Digital by way of WorldTech, and now I'm over at Tempered, and we all have, I guess, similar stories and compatibility. Well, then we'll talk a little bit about that, how we all work together. I'm gonna try not to do death by PowerPoint, and I'm using Tom and Brian to keep me honest. Because I talk fast, I tend to talk really fast, and I can definitely get in the weeds. So I'll try to keep it high level, and Tom's going to be surprised because I promised him I'd send him a preview of this so he could comment on it and guide me, and I didn't do that. So I'm going to try it out today on everybody, so just trust you guys. Let's share this real quick, and I'm going to go ahead and put myself in presentation mode, and we'll talk about this. Okay, so we'll skip this. We'll go back to that particular, there we go. Welcome to day 2 of cybersecurity, by the way, since that's the topic of today. I think you're gonna have a lot of fun. We are going to kind of take a little bit of a step back on this and look more from a bigger picture perspective. So hopefully this will be fun. If you're familiar or you sat through the GE sessions, then you'll recognize some of the verbiage that I'm going to use in some of these diagrams. So I just kind of want to make that part of it a little more comfortable for all of us. And if I move this over here, Tom, do you see that in front of my screens at all?
No.
Okay, good. Wasn't sure how Zoom displayed that. So if we go back in the 50,000 foot view and kind of talk about what this means, really it's that technology and connectivity lead to efficiencies and value, right? So we're all being pushed down this path, whether you're a turbine operator or whether you're some cog in the wheel. We're down this road, and we can't change that, and there's reasons for that, right? It's all about business intelligence, getting more efficient. GE talks a lot about the digital twin, predictive maintenance. Now what's happening though is that the digital is also being used to attack the physical. And that's really what's happened, because this is necessary for us. We're actually exposing ourselves in a lot of ways. So according to Pwnimon and Global Megatrends, you throw out all these numbers, right? They say 66% of our infrastructure is not repaired. And at the heart of it is, why are we doing this? And why are we opening ourselves up? We already had risk before in OT, now we have much more risk. But obviously it's the trade-off, right? The approach is different in every industry, but in physical and cyber physical, there's large amounts of waste. We talk about, we're focusing a little bit on water today. There's some water districts that I'm doing projects in right now, where through that whole process, before it gets to my house or whatever the process might be, there's 40% waste. Manufacturing, food and bev, that's a big part of why we're doing this, why we need the analytics and why we're building in the efficiencies. And we're honestly just not getting around to maintenance in a timely fashion. So, and I want to talk a little bit about, before we start too, about why we're talking about security then today. We always say, safety is a priority in any network. So should be security. So without these efficiencies that we're gaining, we wouldn't still be in business in a lot of cases, and that's power gen, smart grid as well. So security, to me, if you ask me about it, it's actually the enabler. Now, if you talk to your executives, they always see security the opposite, right? It's an inhibitor, it causes problems, makes things more complex, and part of it's because we're kind of bolted on after the fact. But if we're going to deliver on any of these promises, everything that we're talking about, and even what Bayshore is talking about to do, without security, without keeping these systems running, then we are never going to be able to achieve those goals. So we're going to talk a little bit about Airwall later, think logical air gap. That's kind of why we named the product. We have a trademark on the product. And I'm going to throw up a blob next, because what's a presentation without a blob, right? So we need bubbles. Now, let me explain why we're doing this. So this is just to say, you guys can look it up. It's informationisbeautiful.net. They aggregate data and they can build graphs from them. So you can use this, right? What it's showing here is that we've been caught in the loop of the reactive. Like Brian said, everything's about visibility. What does visibility get you? Well, it tells you you've been hacked, and it tells you you're visible, and so you can expose what your issues are, but it doesn't really solve them. So we're kind of caught in that loop, and it's become the new norm. And it's really not acceptable, because we throw around things like, well, it's not how, it's when. And then that's the statement people make. And security vendors then will use that as FUD, and then they tell you have to buy my product because I'm going to protect you and make you better. And then we just spend more and more money, and it turns into expense and death, right? Which is not the way we want to go. So a lot of these are commercial. They're not really, our business. But if I just go back even to 2013, the New York dam, 2014, the German steel mill, then we had the Ukraine power grid, we had Finnish smart buildings, Saudi oil, the US smart grid, 2019, two huge US municipalities. And then earlier this year, there's a global auto manufacturer, right, that had these breaches. Well, they're exploits that led to breaches and actually brought down production lines. So what we're going to do now is discuss, instead of following the breaches, instead of reacting, leading to just compliance and regulation, why can't we get ahead of it, right? What if we eliminate the breaches altogether? That's the panacea, right? So traditional networking is on the left. That's what we've been doing. And then we're trying to talk about a new way of doing things, another way of thinking about things. And there is technology to support this, right? Why don't we start talking about things like, can we make our devices invisible, right? Can we simplify things so it's not so complex? And one of the biggest problems we have, it's still a high percentage of security is, mistakes and fat fingers and people that lateral threats that occur because we don't configure things properly, right? We do internal firewalls, they're complex, right? In the case of Bayshore, at least, we're putting those down right in front of the PLCs where they have the most benefit and the most impact. That's the layer you want to concentrate on in a lot of our businesses. But then all these things are tied into other parts of your business, and sometimes they're online, sometimes they're in the cloud. There's a hybrid approach to this. What about all of that, right? So it gets very complex. So traditional solutions don't work. And I just threw a lot of IT jargon on it, which I think I promised as well I wasn't going to do. Let's walk through what we need. So let's start with some of these things. So you're familiar with this, right? So, I put a big question up there: are we secure? Because when I would go to a GE plant, we do the initial interviews. This is what they would give me, right? This is what I was tasked to do: is decipher this, lay out the network, and for me, look at the communication components, right? And where would our product fit? Why would it fit there? How are we going to implement it? How are they going to manage it? How is that turbine operator going to understand it so you can operationalize on a daily basis? Changes. So this is what we started with, right? How do you know this is secure? And how do you even know this is accurate? First of all, can somebody get in and move around? How big is the attack surface? Have you segregated properly? Are systems in the proper layers and zones based on function? Are there vulnerabilities I have to address? Can I even address them, right? A lot of those systems are old, they're antiquated, they're legacy. Can I preserve those systems? They're impossible to patch. I don't take it down, I'm never gonna reboot it. What's the impact of a change on my network? How much of this is actually compliant because I do have regulations, all right? Will I still be safe tomorrow? So these are all the questions you have, initially when you sit down with these teams. They don't really want to hear all of that because availability is key. I want my plant to be up and running. I want to do predictive maintenance on that, and that's really what I care about. I need production, right? And if I can maximize production, then I'll talk to you. So that's usually we talk about. So part of that too is, can I even do remote access? How do I securely allow remote technicians, right? So you talk about the Moxa MRC, that's a solution that does that. That can integrate into our overlay footprint as well. So all these are going to come into play as we kind of move forward through this. My arrows, there we go. Not going to dig into this. This is just setting the stage, right? This is just our common operational picture. We all understand what all these components are. So SCADA is obviously serial based, it's IP based, there's multi-protocols. What really I want you to get out of this though is that since we already know all of this part of it, the working components, for me as a security architect, it implies supervisory versus control in a lot of cases. And to me, that's the most important concept, because if I look at that, when I go down to the PLC, in most cases, there's only 1 degree of separation now from the critical control. So we've got remote stations in this prediction. I've got local production. They all interoperate. If I'm in like a food and bev type industry, right? If I can, disrupt one portion of that process, maybe it's the bottling line or even the labels, it offsets and puts back pressure on everything else that's running in that particular operation. So zoning is really important. The segmentation is going to be key. And of course, all of these things, if I violate security in one section, does it affect everything else? So we want to talk about that too. And there's some vulnerable systems here, a little bit lagging, so I apologize. There are vulnerabilities in the system, right? So I just put a little red. And these aren't necessarily random. It's just meant to give you sort of a cross section of what we're looking at from vulnerabilities and trusted access perspective. Do we know where things are properly? Where are my field technicians? Are they qualified? Are they authorized? If they're remote, what can they see when they get in? I'm allowing remote access. Can they see things that they shouldn't see? Is that the remote technician that I know? Does he have authorized credentials, right? Or did he get something compromised? Or is he, one of 100 Siemens engineers that shares the same account that comes in to do remote access and do field repairs or things like that? So there's a lot of different questions. One of the things I used to do when I pull up in front of a power plant is I would sit in the parking lot for a while and I would just do scans of the RF and the radio signals, and the Wi-Fi is there, right? In the admin buildings, things like that. And then, I'd be there 20 minutes, no one would come out. There's cameras up on the fence line. I'd be in my truck just sitting there. Eventually I'd go buzz myself in. Now I called ahead of time and I said I'm from GE, so they just let me in. I'd go into the building, almost never check my ID, gave me a badge. Here, sit in the room, we're gonna bring you the CAD drawings. So I would sit there and I'd get my balance of plant drawings. I'd be going through everything and they would give me whatever I needed. I would plug into a jack in the wall, I'm in. I'd log into their Wi-Fi, I'm in. So what's important about this is we need to start thinking about the security on the network and the communication infrastructure, just like we think about physical security. We can't have one without the other. So that was also a piece of it. Now I'm inside, and what can I do, right? So security audits and vendor access and all of that still applies. And then of course, the ICS cert formalized a bunch of findings that we did. GE, we did it. HP's done these as well. Simple little test. You go to that same parking lot and you put a thumb drive in the lot with malware on it. We all heard of Stuxnet. I don't want to talk about that, but little thumb drive, put it in the parking lot. If I had a GE logo on it, 78% of those thumb drives ended up in an HMI or some sort of system, some Windows PC in that control room. If it didn't have a logo on it, so it wasn't quote unquote trusted, I still had a greater than 50% hit rate, which is phenomenal, right? And that's the behavior. Because portable media and things, it's important. That's how we get things around. We sneakernet things, in these environments, and it's just second nature to plug these things in. So that's another security layer that we have to talk about. How am I doing out of time, Tom? Okay. And you can virtually kick me under the table, by the way, if I'm just jabbering on too long.
I was trying to answer you. You've got time.
Okay, good. Because what I want to do now is kind of go into and I'm not going to do a lot of selling. Once again, I apologize, you got the engineer, so I'm going to do my best here to not oversell things and do a lot of marketing. This is, and I'll talk about the components of our solution a little bit. Those little yellow badges, right? That's our new logo. And Tempered Airwall is, it's a solution that incorporates things like hardware gateways. It could be those, it could be agents, it could be pieces of software. These are sort of the control points that I look at when we look at these systems. So it's not a lot different. You've probably already got, your Bayshore stuff's probably already going to be in there. So if you've got SCADA fuse down in those networks, we're going to be on, on the other side of that. And I can talk about how that interoperates probably in a different session, but we've been in networks where we interoperate together. And so we're going to be another layer. I know you don't want to hear that, or adding more stuff. The idea here is to make it a little bit less complex for you, and we'll talk about how that happens, but these are now going to be an overlay. They're not actually going to disrupt and we call it an overlay for a reason. Everything else that's communicating underneath us still communicates the way it's supposed to, unless we're intercepting any of the control paths. So we're adding encryption. We are adding tunneling to these things, and it'll become clear in a second why. The deeper I go into a network, the more segmented I can become. So if you disrupt one part of the functioning process, you don't disrupt something else. So that's one way to go, which is why on the left-hand side of the remote stations, you see I'm a little more segmented and granular there than I am over in the local production. And that's just going to be based on what those systems look like, ease of use, and we're going to balance the risk versus cost in some of these networks as well. So that's this is where we would play. Now on the field technician standpoint, it's going to be a little bit different because we're talking about people on site being secure and authorized and authenticated in the same fashion as somebody who comes in remotely. There's really no functional difference except for distance. It doesn't matter if it's the internet, and I know people are going to think I'm crazy for saying that. It really doesn't matter where. With these authenticated encrypted sessions coming in, now we can do pinpoint control and authorize these people right down to the very piece that they're supposed to be working on and nothing else. So if a Siemens engineer is doing remote maintenance or looking at something, that's all he sees. He can't get into the network. So if he's been compromised, he can't pivot to other places in the network and look at other things and kind of look at any other control systems other than what you allow him to do. So we're going to remove that whole complex layer of firewall rules and VPN access and ACLs and all of that stuff that the IT guys like to deal with on a daily basis. The idea here is to give that to you, give you an operational interface that even I can operate, right? Somebody without a degree in managing this. So a turbine operator basically will run this, on a daily basis. So the components look like this. We just call them things. We're going to manage things because that's what IIoT and the Internet of Things world likes to call them, but it definitely started in our world. And so that's what we're going to talk about first. So there are gateways, there are pieces of hardware. The reason these are important is when I mentioned you can't put agents on PLCs. You can't patch legacy systems. You can't patch your control and your application servers and things like that that are running legacy software. So we're going to protect those. That's a legacy investment that we need to stay in place. And if you need to look at compliance things, obviously if you're in electrical industry and stuff, and look at CIP 5 or whatever it might be, we're going to now allow you to check those boxes and become compliant in a very cost-efficient way without any disruption. And Brian's got a story that he'll probably tell you about too, that, not disrupting your network while we implement is really one of our key pillars that we live on. So those are just the things that protect you down the bottom, right? Software or hardware or whatever you need, we package it whatever you need to be. The relay is really how we can do routing internally. You typically never need us to worry about that, but if you are connecting different sites, non-routable sites, we have a huge oil and gas customer that obviously everything's layer 2 and not routed between locations. We will use a relay to do that. It's a really clever piece of software that allows me to connect these quote-unquote logical air gap systems together with never having be able to see each other without that relay, right? So the relay allows us to stitch those together for communication reasons. And then a conductor is really how everything is done. That's going to be our management or configuration interface. So if there's anything I need to dig deep in now, let me know, or if anybody has any questions.
No questions at this time, Kevin.
Perfect. Okay, so I'm going to go through a scenario and we'll dump into sort of the demo piece just to show a little bit of the interface. I picked on water just because I know that's what a lot of you are dealing with on a daily basis. That's where you're from. That's the world you live in. So I just picked a utility, a municipality that I work with. And there's several of these that we do business with. So one of our largest industries, I'd have to say, is probably going to be water and wastewater. I think all the other ones do apply, oil and gas, power gen, even healthcare. So there's a question that came in. So you want me to answer it now since it's kind of in line?
Yeah, please.
Okay, Tom? All right. So John asked about an intuitive way for creating VLANs. So, and that's really part of it. There's two parts to this question. One is also replacing firewalls. So the VLAN piece of it, really got complicated as we went down this path. Now, initially it was kind of required, right? We need to segment. What's an easy way to do that? I already have switches. Switches can do it. I can do it on a layer 2 basis. I don't have to do really expensive technical things to do that. So there's definitely a place for it. There is a more intuitive way and an easier way to do it, right? And that's part of what we do from microsegmentation. But we'll adopt whatever you've already done. So if you have done that segmentation with VLANs already, great. We'll start from there. If you don't have them, but you want to do the microsegmentation, then we'll do it with, we have a port security methodology that we use that we do all that without having to use VLANs. So I didn't really answer your question, but there is a definitely easier way. And I'll show when I kind of just do the drag and drop. What happens behind the scenes is really what we're going to hide from you, but all that complexity sort of goes away. Replacing a firewall, it can. This solution could definitely obviate the need for it. For the most part, since everything's encrypted in flight, the firewall really isn't doing much inspection anymore. But there may be things that are not part of our overlay, so those firewalls are still very, very necessary. And of course, I mentioned, with the SCADA fuse, it's still going to be there in front of that PLC. It simply is an endpoint, that we are now talking to, and it's doing the grammar correction and doing all of those things from the control level that we're not doing. So there are places where that firewall is still really, really important to leave in place. There's other places where it's not necessary, like the remote access piece now, and maybe sometimes the edge. That firewall could be obsolete, but for the most part, normal hygiene kind of stays from the IT side. And that's what the challenges were here. So that leads in really kind of nicely to this, is that, this district, despite being very large, I mean, we're talking long haul fiber of 31 miles in some cases, right? But even despite all of that, they're all layer 2. There was no segmentation at all. There were a couple of places back in the control center and the application side that had some VLANs only because they had virtualized their applications with VMware. So other than that, there was nothing that had been segmented. So there was MAS radios, which is all the analog stuff. They had digital, they had long haul fiber I mentioned. They were even doing Wi-Fi point-to-point in a couple of places just to nail it up. And then of course that meant no vendor access. Anytime there was an issue somewhere, they had to go to a lift station or whatever it might be, that was a truck roll. It's really expensive. So all the things you can imagine here with systems going offline with no insight, that's what they were dealing with on a daily basis. So we took, and this one actually took 3 weeks, it didn't have to, but they were replacing all the radio systems, actually putting in their own dark fiber, and doing some other things to actually fix the underlying network too, which is what it took longer. And then we were able to implement basically, the part that we did probably took 3 days at the most. No re-IPing, duplicate IP subnets and things like that, and duplicate VLANs, it doesn't really matter in our product. So the result then, we go forward, and we call it zero trust, which we didn't really talk about. I don't like using the word. That zero trust really is a methodology and a concept and a framework. It's all of those things. It's not really a product, but it's a concept we strongly believe in. So this is really what it looks like afterwards. So despite where you are now, if that control system or that application, if we just take the lift stations as an example, they can now be in their own functional process groups, across these distances through this underlay network is part of what we call the overlays. You look at yellow. Yellow talks to yellow, and that's it. If a remote vendor comes in, you give them access, which we're doing as our next phase, they can see an entity inside of that network, and that's it. They see nothing else, right? So the segmentation was really key, the functionality based on that, and of course that means efficiency gains, easy to operate, we eliminated conflicts, troubleshooting was much easier to do, and now we can actually create a secure vendor network, right, and eliminate all those truck rolls we talked about. So let's go real quick, just show you the conductor. This is the management interface. I'm going to flip over. Now, the idea here is this is the interface that can alleviate the burden on the operations team, right? So it's about automation, easy user interface, good for updates, alerting, all of that. But it has to be really easy to use on operation on a daily basis. So I'm going to stop this for a second and flip behind, and hopefully I'm still logged in. I'm going to move you to over here. And if there's any questions that come in, just yell at me. So this is just a web interface right into our dashboard. So there's a couple of different views I'm going to go through here. I'm going to start here first on this screen. If we go to really large networks, and we have some that are, over 10,000 endpoints, right? And if you start getting into a big smart grid, say you're dealing with SDG&E or somebody on like Southern California or some of the bigger ones, when you get in those scenarios, you have to start working with things like in groups, right? So we've built functional groups. So if you think back to the ISO 99 or the Purdue model, we put everything in zones and groups. And then you also tag them based on function and location. That's really how we're going to work with things in here, right? Does that make sense? So if I'm dealing just with lift stations, I can do either all my lift stations in one area. So if I can say, like my Atlanta lift stations or whatever the city happens to be. So if I'm Orange County Water, and I have these segments and these buildings, I will deal with that by labeling things and putting them in groups. So that's a big deal, because how I secure them is really how I can identify how I can work with those particular entities. So let's go into what we call an overlay. Remember, I keep saying the word overlay. I want you to understand what it is that this is really the security policy. So if I have all of my entities in here, so say you're using like Bayshore scrutiny or something, right? You're doing asset enumeration and you're monitoring all the devices and you feed that information to us. We can then build an asset database, which allows you then to just have these named, labeled, where they are, and I can now build policy between these units, right? So from a visualization standpoint, it's gonna look like this. It's a nice drag and drop GUI. Behind the scenes, you already know I have all these devices in my network that I'm controlling. But if you look down, I've got my PLCs, I've got my meters, I've got different applications monitoring those. And every one of these blue lines doesn't have anything to do with VLANs or firewalls or network connectivity. These happen to do with policies. So I build a policy on how I want to access things. My SCADA secure access is somebody from the outside, where are they allowed to see? So vendors in this space that I've allowed, say if I've got Siemens or and whoever supporting me, Roche Controls, whatever it might be, they can then come in and they can see just their system and nothing else. I can even build this all the way down to the meter if I want to and bypass everything else. And I do all that really just by a couple of things. So if I look at, let me look at the remote vendor access first. So the SCADA access right now, I gave them access to a couple of applications. Let me just take that off. Right, so I've essentially, if I go back to my visualization now, as soon as it builds, you can see I remove, over on the right, I remove trust. Now, in a normal traditional IT network, love my internet today. This is why we don't work from home. In a traditional network, what did I just do? I changed VPN policy. I might have quarantined them, I don't know. I definitely have ACLs, I've got firewall rules, whatever it is, I changed a whole bunch of things. What we just did here is, you remember we do encryption, right? And we also do authentication. I've just run a whole PKI process. I've exchanged keys, I've authenticated a user. And then in the reverse, what I just did is I took all those credentials away, just like that. So you can see how easy it is for any operator to say, okay, I need to provide access to this Siemens technician on Thursday at 2 o'clock. He can do that. And Thursday at 4 o'clock, he's done. You can remove that access. And that's how easy it is. So the complexity is completely removed from the scenario. And the same thing applies with looking at applications in HMI. Those, we just simply build those controls into it, and then you end up with it look like this. Now, as far as what's under the hood, this is what it really looks like under the hood. All these RA people are the secure remote access technicians out here. And then you can see across a couple of distances here, and this isn't actually, it should have been in one city, in a municipality, not two different states here, but I'm actually connecting across a couple of different, 3 different network locations across the US with these application servers. So that's what the network really looks like underneath. But all we really care ourselves about is what our network policies are.
So Kevin, that's kind of cool. I mean, what I'm seeing here is it makes it a lot easier just to rearrange things based on access levels, whether or not you want someone to come in and work on something. It's easy to make a quick change and you can sequester them in the meantime.
Yep.
We've also got a time check here. We got about a minute or 2 left here, and we should stop about 5 after.
Well, we're good. We're good. So I think we should do some Q&A, because I think right now I'm probably a couple minutes over. That's good.